Hello, my name is Emery Hill, and I will be presenting my lab on electric charge part 2. The purpose of this experiment was to use Coulomb's law to calculate the electric charge between two pieces of tape, one floating above the other. This time around, the tape was treated as a line of charges rather than a single charge like the last lab. Doing this, a computational model was created to make the calculations and a visualization. So for a preview of the main results, you can see here this was my result, and we have the magnitudes of electric and gravitational forces there. Uh, this line of spheres, those are the tapes, and the arrows are all of the forces. Behind this, we have Coulomb's law at work, which just is the basis for all of the electricity stuff, the electric fields and electric forces. And there's the formula right there. And then a little bit deeper, we have charge distribution. Not all of these are required for this lab in particular, but basically those formulas are how we account for multiple charges rather than single point charges. And then we have Newton's second law, which is important for gravitation, and it's kind of the basis behind everything as well. For the models and software, GlowScript was used to create the model you saw before. The green is the electric force arrows, the white is the net force, yellow is the gravitational force. To recognize the system, surroundings, and initial conditions, this is a picture from when we were doing the lab. The top tape is the system, because that's what we're focusing on, and then the surroundings are my air, my hands, the other piece of tape, everything else. So the bottom tape is at the origin. The top tape, while we're looking at it, is at a height 5 centimeters above the origin. The length of both tape strands was 0.2 meters, and the width was 0.01905 meters. For the procedure, it's the same as the last lab. And as you can see this picture over here on the right, that is my result from the last lab, and this is the new one. So two pieces of tape were charged by separating them very quickly, and then the height one floated above the other was recorded, and the electric charge was calculated using Coulomb's law in gravitational force, and then using, this was in the last lab, and I just felt it was kind of important to keep it in, using the surface area of the tape and atoms per meter squared, the number of atoms on the surface of the tape was calculated, and then we did that calculation based on the percent that was lost. So here's kind of the bulk of it. I just have some pictures. Some of them are more zoomed in than others because there's a lot going on in this middle one. But this is the coding from GlowScript. The initial variables are the top, just the constants. The creating the tape strips and initial positions, that's this middle one here. Calculations for electric forces and arrows, that is this huge one right here. And then our electric field calculations down here. You can pause if you would like to look at it a little deeper, but those were my calculations. For the analysis and conclusion, the result was around 3.9 times 10 to the negative third coulombs for the magnitude of the charge on the tape. That represents the charge of one piece of tape. And then last time we represented the tape as a point charge. This time it was a line of charges. This is a little more accurate, but we still made some assumptions, including that the tape was just a line. It didn't have depth, which is a difference. And then we also assume there's no air resistance on the floating tape, and that the charges were evenly distributed along both tapes, which could have not been the case in reality. Overall, though, the experiment was successfully conducted. So to answer some final questions, the differences between a single charge and a line of charges. Well, the value of a single charge on one tape in my previous lab was about 8.8 times 10 to the negative 8th coulombs. In this lab, it was 3.9 times 10 to the negative 3rd. So that's a big difference. Part of that difference is due to a minor miscalculation I made in the last lab, but the numbers would not be the same regardless. Why is there a difference? Modeling the tape as a line of charges is more accurate. Realistically, there's a very high number of charges on the surface of the tape, so the closer we get to that number, the more accurate the data will be. Modeling the tape as a single charge is less accurate because it only captures one angle and one charge, and we're representing it all in the same place, which it's not really. So for some potential errors, there's always human error, which is possible when we're dealing with those tapes, especially if they touch other objects or my hands, that could remove some of the charge. Then again, measurement errors. The tape was floating. It was moving a little bit when we measured it, so you can't be sure that's perfect, a perfect measurement. And then again, in the calculations in the code, messing up one plus or minus sign could completely drastically change the results. So that's another possible error, but I do not think that occurred. Thank you for listening.